Good morning, students. During the last classes, we have discussed about the methods of preparation of amines. Also, we have discussed about some questions based on methods of preparation of amines. In the last class, we have gone for solving the questions based on the molecular structure of amines. Also, we have gone for conversion of one organic compound into another organic compound based on methods of preparation of amine. Also, we have gone for identification of A, B, C, D type of questions based on the methods of preparation of amines. Now, we will discuss about the chemical properties of amines. See, when we consider about the chemical property of amines, it is the behavior of the nitrogen atom present in the amine that decides the properties. See, in the amine, the nitrogen atom is sp3 hybridized, and out of the 4 sp3 hybrid atoms, though 3 are attached to hydrogen atom and alkyl group, one sp3 hybrid orbital is remaining as a lone pair of electron, and this lone pair of electron present in the nitrogen atom makes the nitrogen atom electron efficient. Due to this electron efficiency nature of this species, the amine can behave as a nucleophile. The nitrogen atom of nucleophile, due to the electron efficiency, it can act as a nucleophile. And most of the chemical reactions of the amines is due to of these reasons. So we will discuss most of reasons where the nitrogen atom of the amines will behave as a nucleophile, and accordingly the products will obtain. So like that, first of all, we will go for the alkylation of amine, then we will go for acylation, okay, and also we will discuss about the benzoylation, okay, and many other kind of reactions, okay. First of all, we will go for alkylation of amines, okay. Alkylation of amine. So alkylation of amine already we have discussed in the haloalkane chapter. What happens here? Amines react with the haloalkanes to give what? A substituted amine. RNH2 plus RX give R2NH. That means the primary amine will lead to the haloalkanes to give us secondary amine. Now the secondary amine will again lead to the haloalkane to give a tertiary amine, and the tertiary amine can again further react to give a quaternary ammonium salt. Okay, so amines react with the haloalkanes progressively to give secondary, tertiary amine, and even if finally quaternary ammonium salt. The whole process is, if I take R N H H to RNH2 plus 0 R X. R was a CS2 X. Okay. Now what happened here? This, you see, this lone pair of electron present in the nitrogen atom make it electron efficient. Now it can act as a nucleophile. Now here we have the high electronegativity of this X atom. It can go there by creating a point charge here, electron deficient center. Now when it becomes electron deficient, now this will attach to what? This one. So we will get what? We will get what? R N H H C H2R plus plus. Okay, because when this bonds goes to here, it becomes C plus. Now nitrogen with this one electron will come to here, so the plus star is shifted to that atom. Now it becomes unstable. Okay, so what happened here? Now this one will come to this one. Okay, so we'll get what? R N H C H2R plus this X minus and this L plus. Which one? X. So this is what you Amine RNH2 now becomes what? RNH2 again R because what? Substituted amine. Second, this will again further reaction to give what? Now this will replace R C to R M. That will again further react to give what? Quaternary amine salt. So this is the process of the reactions. So when amines react with halo alkane, so this alkyl group is attached to the nitrogen atom. This is called alkylation of amine. Clear? Again I am writing the amine RNH2. The N lone pair of electron is acting as electron epicenter center. In the halo alkane, when we see hydrogen atom is taking electron pair to acid because of C minus effect. Now C becomes plus electron deposition center. So this N electron emission attack to what? The electron deposition. And we are getting this one RNH2 C2R. Now this plus charge of the carbon is coming to what? This is nitrogen atom. Now making it unstable. So what happens here? Now this nitrogen will take up this electron pair to acid and release as a proton H plus. So here already we have X minus, already we have H plus here. So they give what? HX. So I can simply write R N H H plus X R. Okay, minus HX will give what? R N H R. Okay, so this HX will remove, will get what? R2NH. Okay, again this H will remove, will get what? R3 and so on. Okay, so what I will write? What I will write? C. So I will write C2H5Br. So C2H5Br plus C2H5NH2. Your ethyl amine, what your ethyl amine, ethyl bromide will give what? C2H5NH C2H5 plus HBr. Okay, it's your Br and H. Now again C2H5 whole to NH plus Br C2H5 and what? Okay, C2H5 3N plus HBr. Okay, now C2H5 whole 3N plus again C2H5Br will give what? C2H5 whole 4 and plus Br minus. Okay, so this is what your ethyl bromide, ethyl amine, what your primary amine. Now this primary amine react with your ethyl bromide. Okay, where HBr removed, we are getting what? Second name is called the diethyl amine, called what? Diethyl amine. Diethyl amine. Now this diethyl amine further reacted C2 is equal to NHO plus C2 we are again given what to tertiary amine called what? Triethyl amine. Now again this triethyl amine further reacted with ethyl bromide to be what? Quaternary ammonium salt. Hello? It's called tetraethyl ammonium bromide. Tetraethyl ammonium bromide. So this is the process of alkylation of amine. So in the alkylation of amine, the alkyl group is attached to the nitrogen atom of the amine by replacing the hydrogen atom. RNH2 plus RH2, so HX will remove, we get R2NH. Okay, so these amines progressively the hydrogen atoms of the NH2 group will be replaced by the alkyl groups. We get secondary amine, then tertiary amine, then quaternary ammonium salt. Okay. Alkylation of amine also can be carried out by your aromatic amines. If I take aniline, same process will repeat. So aniline, they go for what? C2H5Br minus HBr remove, we get what? NH C2H5 again C2H5Br HBr remove, we get what? NO C2H5 whole 2. Okay, now C2H5Br. Okay, and get what? N C2H5 whole 3 plus B minus. Okay, so this is your aniline. You are N-ethyl aniline, and this is what your NN diethyl aniline. Okay, this is what your triethyl anilinium bromide salt, quaternary ammonium salt. So this is your primary, secondary, tertiary, and quaternary ammonium salt. Clear? So both aliphatic and aromatic amines undergo alkylation to give progressively primary to secondary, then tertiary, and even finally your quaternary ammonium salt. Clear? So next unit we will go for what is the acylation. Okay. Next we go for what? Acylation of amines. Number 2. Acylation of amines. So acylation is the attachment of an acyl group to the nitrogen atom. The acylation of amine can be carried out by taking the reagents like acetyl chloride or acetic anhydride in the presence of strong base like NaOH. So when amines react with acetylating agents like acetyl chloride or acetic anhydride in presence of strong base like NaOH, then acid substituted amides are obtained. Okay, so when amines react with acetyl chloride or acetic anhydride in presence of strong base like NaOH, then substituted amides are obtained. This is called acylation of amines. Let us see, if I have suppose I have CH3, CH2, NH2. What do? Ethylamine. What do? Ethylamine. Okay. Now this, if I take here CH3, C double O, Cl, called what do? Acetyl chloride. Or what? Acetyl chloride with the base value NaOH. So what happened here? You see here C3COCl. This is a your C double O having a sigma and pi bond. So what happened? This pi bond can come to this place. So this C becomes what? C becomes what? Plus electron deficient. Now this negative is electron deficient here. So this will come to what? This. So we will get what? CH3, CH2, N, H, C, O, CH3, Cl. Okay? Plus. So this carbon becomes plus by breaking up this pi bond. Now this carbon plus is electron deficient. So the net atom having the extra electron pair, electron efficient, act as a nucleophile, and this will attack to this carbon. We will get what? This one. CH3, CH2, N has to plus this plus of carbon will come to this net atom. Okay? So N plus, then C, CH3, Cl. Now then after, what happens, you see, because this net atom containing the plus charge is unstable, it takes this electron pair, this bond towards it. So it goes to H plus, and this pi bond comes this way, and this chlorine goes to H0 minus. Okay, so when this H goes away as H plus, this minus charge comes here, becomes the pi bond. Now Cl goes. So Cl minus H plus. As what? HCl. As what? HCl plus what? CH3, C double O, NHO, C2H5. See, CH3, C double O, then NHO, C2H5. This is what? N-ethyl acetamide. N-ethyl acetamide. Okay. So amines react with acetyl chloride in presence of base to give what? M substituted amides. So simply if I write the reaction like this simply, you see, CH3, CH2, NHO plus Cl, C double O, Cl. This H plus and Cl minus goes out. Okay, and we will get what? We will get what? CH3, C double O, NHO, C2. N-ethyl acetamide. But how is HCl goes? This is the way. First of all, this amine attacks this carbon, electron deficient, okay, and we are getting this one. then after D, there is your deprotonation. Okay, H plus will remove here, C minus will remove. Again, this pyramid will form and will get for this. Clear? So now this thing also I can write by taking second ring. If I take CH3, C double O, Cl plus H N C2S5, C2S5. Okay, base. Same thing, H plus Cl minus. Okay, we get what? CH3, C double O, N, C2S5, C2S5. NN diethyl estamate is what? N, N diethyl acetamide. Now this acylation again I can do with the help of our acetic anhydride. Same process, same thing. CH3, CH2, NH2 plus CH3, C double O, C double O, C. This is what? Acetic anhydride. What? Acetic anhydride. Okay. Now what happens here? See this is the anhydride group. So this will break here. Either to this side or from this side. We get what? CH3COO minus and CH3CO plus. This becomes what? CH3CO plus. This is what? CH3CO minus. So what happened? Now this is nitrogen atom, N electron efficient will adapt what? This carbon. Will get what? CH3CO, NH2, CO2, and this H2 and CH3CO minus will give what? CH3COH. So we'll get what? You are get what? CH3, C double O, OH plus. Okay? Again, CH3, C double O, NH2, C2. So, N-ethyl acetamide. N-ethyl acetamide. Clear? And acetic acid. What is it? Acetic acid. Okay? And now this reaction also I can do by taking your second ring also. Okay? Let's see. CH3, CH2, N, CH2, CH3, H, second amine, okay, plus if I take CH3, C double O, O, CO, CH3, okay, this one comes here. So when this one comes here, this O becomes minus, this C becomes plus. So this N now comes what? To here. Okay. So finally we will get what? This CH3CO minus, okay, and this H plus. Get what? CH3COOH plus in what? CH3CON C2S5 C2S5. Okay. So NN diethyl acetamide. NN diethyl acetamide. What will N, N diethyl acetamide. Okay. Similarly, the aromatic amines Amine also can react. If I take NHH aniline plus Cl C-double-bond-O C3 acetyl chloride base of base. Okay, look at what HCl plus CH3 C-double-bond-O NHO N-phenyl estamide is what? N-phenyl estamide. Okay. Now, if I take NH plus CH3 C-double-O C-double-O C3. Okay, CH3 CO minus H plus CH3 COH. Okay, base you want to CH3 COOH plus CH3 C-double-O NH. Okay, so again what do N-phenyl estamide or acetanilide. Okay, so aromatic amines also react with your acetic acid or acetic anhydride with some base to give value substituted amides. Here also we can take secondary amines also I can take. If I take suppose, if I take here suppose I have a C2H5, then I will get what here. Okay. Similarly, if I have a C2H5 here, secondary, okay, I will get what C2H5. So here N-phenyl estamide, N-phenyl estamide. Okay, so this is the acylation of amines. Okay, so next is here action with the nitrous acid. See, nitrous acid HNO2 is unstable, so we are preparing this nitrous acid in C2 by taking NaNO2 and HCl. So whenever we need HNO2, we cannot directly take HNO2 because it's unstable. So what we are doing, we are adding NaNO2 and HCl to the reaction mixture, and in the reaction mixture the HNO2 itself is forming and that is it. So primary amines react with the nitrous acid to give a primary alcohol with brisk effervescence showing the evolution of nitrogen gas. Okay, so primary amines react with nitrous acid to give a primary alcohol and nitrogen gas is evolved at low temperature. And remember, these reactions can be used as a test for primary amine because other amines are not evolving nitrogen gas. So if we are having an amine and we are treating with the nitrous acid, NaNO2HCl, and nitrogen gas is evolving, this means the amine is the primary amine, right? So if I write CH3 CH2 NH2, okay, plus HONO, NaNO2 plus HCl 0 to 5 centigrade, low temperature. You can what this will happen. HONO, OH NO. Liquid water CH3 CH2 OHO plus N2 plus H2. Okay, so ethyl alcohol. Okay, this is what your ethyl amine. So when primary amines read with nitrous acid HNO, that is NaNO2 and HCl in situ at low temperature, then the primary alcohols are obtained with the evolution of nitric gas. Okay, and this reaction, you see, this is an important reaction. So, and this reaction is basically when we are going for conversions. Whenever we have to convert into alcohol from the amine, then we are using this reaction. We are reacting amine with the HNO2 and we are getting an alcohol. Then from the alcohol we can go for aldehyde, we can go for acid to amide, and many things. And also these alcohols can come to haloalkane. So many kind of conversions we can do once we convert amine into alcohol. Okay. Now if we take aromatic amines like our aniline, then aniline react to nitrous acid, NaNO2 and HCl at low temperature in a different manner. So if I take aniline, okay, plus your HCl, you get what? NH3 plus Cl minus, okay. Then what will HONO, okay, and what will NaNO plus HCl 0 to 5 centimeter. You get what will N2 Cl plus 2 has 2O. This is called what? This is called what? Benzene diazonium chloride. In this process is called what? Diazotization. Diazotization. So primary aromatic amines like aniline react with nitrous acid at ice cold condition. It's called ice cold condition. Right? Ice cold condition to give what? Benzene diazonium chloride. This process is called what? Diazotization. Remember, if you are increasing the temperature from this, then we are going to get different product. So if this aniline will be heated in place of nitrous acid NaNO2 HCl at 50 degrees centigrade, then we will get phenol. That means the benzene diazonium chloride so formed on further heating becomes unstable and convert into what? Phenol. So if I write, suppose aniline plus HONO, nitrous acid, 50 degrees centigrade. Then what happens? OH plus N2 plus H2, phenol, aniline. Okay, so three things are different here. If you take primary aliphatic amine, nitrous acid HONO, that is from NaNO2 and HCl, low temperature, we get what? primary alcohol with evolution of nitrogen gas. If you take primary aromatic amines, that is aniline, it is the nitrous acid HNO from NaNO to NaHCl at 0 to 5 degrees centigrade, that is the ice cold condition. Then we get what? Benzene diazoxide. If the primary aromatic amine, that is aniline, will heat up the nitrous acid HNO up to 50 degrees centigrade, then we get what? Phenol as the product with the evolution of N2 gas. Clear? Now, if you take secondary amine, then secondary amine react with your nitrous acid to give what? Nitrosamine. Secondary amine react with the nitrous acid to give nitrosamine. And to the nitrosamine, if you put a small crystal of phenol and what, will get a greenish color solution. To that greenish color, if you again dilute with water, will get a red color solution. And if you put with the alkali, will get a deep blue color solution. Okay, let's see the reaction. C2H5 hold to NH diethylamine plus HONO C2H5 hold to N1O plus H2O. Okay, it's called what? N nitroso diethylamine. Okay, now this N nitroso diethylamine, okay, yellowish oily liquid. Now when you put crystals of phenol in warm, you get what? Greenish color. Now put water, dilute, you get what? Red color. Okay, alkali, Na also, you get what? Blue color. So this reaction is a test for secondary amine. Secondary amine, when react with nitrous acid, this what? N-nitrosamine. This is a yellowish oily liquid, and this liquid when treated with when warmed with your phenol, will getting a greenish color, and then after this on treatment with your alkali, and also you say blue color, deep blue color. And this deep blue color, and this on dilution with water gives a red color. Okay, so this is called what? Lieberman's nitroso test also. Okay, so this is